So we're going to continue here in section 4.1. We're going to try to finish this section. And we've been talking about one-to-one functions, and we've talked about what it means for functions to be inverses of one another. And in our last video, we talked about how x and y are basically flip-flop between the original function and its inverse. And so if we're trying to find the inverse, which is what we're asked to do here, it says determine whether each equation defines a one-to-one function, and then if so, find the inverse. Now, determining if it's a one-to-one function for most of these is not going to be super difficult, because we're going to know kind of sort of what the graph looks like without having to do anything, okay? And so then we're going to find the one-to-one function. I mean, we're going to find the inverse. And so in this first equation, f of x equals 2x plus 5, the 2x plus 5 we know is a linear equation. Highest exponent of 1, you could graph that. It's got a y-intercept of 5, a slope of 2. You kind of probably have an idea about what that line looks like. And because it's not horizontal and it's not vertical, then it is a one-to-one function. So, I don't really have to show anything else. Just knowing that it is a one-to-one function is really the key here, because then it does have an inverse. And so to find the inverse, we're going to take x and y and basically flip-flop them. We're going to substitute them in for each other and then solve for y. So remember that f of x is the same thing as y. And so y is equal to 2x plus 5. And to find the inverse, we're going to replace x with y and vice versa. So we're going to put x here and put y in place of x and get this equation. And then we're going to solve for y. And when we do, we should end up with the inverse of this function. So to solve for y, we're going to subtract 5. And this is something that you can probably do without a whole lot of issues. And we're going to have x minus 5 is equal to 2y. And we'll divide by 2. And we'll find out that y is equal to x minus 5 over 2. Now, this is now the inverse of the 2x plus 5. So again, if you wanted to prove to yourself that yes, this is the inverse, you could take 2x plus 5 and put it in place of x in the inverse, and you should get x. And you could take the x minus 5 divided by 2 and put it in, and you should still be able to get x. And so you could do that if you wanted to. That's not super difficult to do here, to show that those are inverses of one another. Don't make this overly complicated. Again, you're just taking x and y and flip-flopping them. Okay, that's all you're doing, and then just solve for y. So, look at this one. This one is, the equation is y equals x squared plus 2. Well, it's y squared plus 2. We know, because of the power of 2, it is a parabola shape. Right? And we also know that because it is a parabola, it's not going to pass this horizontal line test. Horizontal line would touch it at 2 different places. And so this one is not one-to-one. And so because it's not one-to-one, it's not going to have an inverse. Okay? And so here, instead of trying to solve for x and y and all that, we're just going to say that this one is not one-to-one. And again, we know that based on the fact that we've talked about the graph in quite a bit of detail, and we know that based on the graph that this has to be a parabola. Okay? So we're just going to say it's not one-to-one, therefore it does not have an inverse. Now, on the next one, we haven't looked at as many cubic equations, but this general shape kind of looks like this. It's not a very good example, but it's kind of this S-type shape. And a cubic equation is typically going to be one-to-one. Now, we could prove that if we wanted to by taking, finding f of a, so putting a in place of x, and showing that that is not going to be equal to b f of b, so b cubed plus 5. And as you subtract 5, you would show, and we did this in one of the previous videos, you would find that a cubed would have to not be equal to b cubed. And then you could take the cube root of each of those. And when you take the cube root, you would find out that a is not equal to b. Well, assuming that a and b are not equal to begin with, then when we get to the end, we're going to have two numbers that are different, two different y values, and so that would be how you could go about showing that it is one-to-one. Again, the graph helps us probably know that. It does pass the horizontal line test, but if you need to convince yourself that it is one-to-one, this is how we would do that. Now, once we know it's one-to-one, we can now go find the inverse. And so again, g of x is the same thing as y. And so we're just going to replace that x with y to find the inverse. So we're going to put x there, y there. And then we're going to just solve for y. And so again, we're going to subtract 5. And we're going to get x minus 5 equals y cubed. And to get the y by itself, we'll take the cube root. And we'll find out then that y equals the cube root of x minus 5. And so there is now our inverse. Again, just flipping x and y and showing that they are inverses. Now, let me talk more about this one-to-one thing for a second. On the previous problem, we said that it's not one-to-one. If you don't understand that and you say, well, how do I know? How do I know it's not one-to-one? Well, if you can put a number in for x that when you square it and add it to, you get the same value for y, that's enough to show it's not one-to-one. So, for example, you could have taken 2 and squared it. Well, 2 squared is 4. 4 plus 2 is going to be 6. And you can also take negative 2 and put it in for x. And negative 2 squared is 4, and 4 plus 2 is also 6. And so because you could get this same y value, it's not one-to-one. Okay, so I don't think I addressed that very well a minute ago, so I wanted to make sure you understood that. And so because it's not one-to-one, we couldn't find the inverse. This one is one-to-one, and so we are able to find the inverse. Now, on the next one. This one too is a one-to-one function. Again, if you go back and you look at our sections on functions where we talked about those, we've seen these graphs that have this x variable on the bottom, and you have a graph that kind of looks like this, where there's a vertical asymptote and there's a horizontal asymptote, and it's one-to-one because as it runs left and right, it never does go horizontal. It's always either going slightly up or slightly down. It's also a function because it never goes vertically straight up or straight down. And so based off that graph, it is one-to-one. Now, if you want to take A and put it in and B and put it in and solve and find out that A would have to be equal to B, and again, assuming they're not the same number, then you could show that it's one-to-one that way. In my opinion, looking at the graph is the easiest thing. Okay, just about every one of these, and I don't want to say always because there could be some example I'm not thinking about, but most of the time, if you have a fraction like this with an x on the bottom, it's likely going to be a one-to-one function. Okay, again, that's not every time necessarily, but every example I can think of, that is a one-to-one function. Okay, so based off of that, we can find its inverse. And so we're going to find the inverse like we've done all the others. We're going to replace f of x with y. And so our function here looks like this. And so to find the inverse, we're going to replace x with y and y with x. And so we're going to rewrite it as x equals 2y plus 3 over y plus 4. Or, I'm sorry, y minus 4. Make sure I have the right sign or we're going to be messed up. Now, you may look at that and say, oh, I don't know how to get y by itself. Well, the first thing we got to do is get rid of the fraction. And so we can multiply both sides by y minus 4. And when we do, the y minus 4 on the bottom and that one we multiply by, they're going to cancel each other out. And so that'll be good. So we can also distribute this x and have xy minus 4x, and that's equal to 2y plus 3. Now let me rewrite all that over here. Now, get to this point, you may say, well, I still don't know really how to get y by itself. Well, let's move all the y terms to the same side. That's a good place to start. So I'm going to subtract 2y. And I'm also going to move the 4x to the other side because I want to get the 4x moved to the right. And so I'm going to add 4x on both sides. And that way on the left-hand side, I've got negative 2y plus the xy. The negative 4x and positive 4x cancel. The 2y minus 2y cancels. And I have this 4x plus 3. Now, still don't have y by itself, right? And negative 2y and xy aren't like terms. You can't put them together. However, both of those terms have a factor of y. And so if I can take this factor of y out and write it as y times some stuff, well, then I could divide and get y by itself. And so if we take out the greatest common factor of y, we're going to have negative 2 plus x that's left. And that's equal to 4x plus 3. Well, now I can get y by itself because I can undo that multiplication by dividing. And so we can divide by negative 2 plus x. Negative 2 plus x. And the negative 2 plus x divided by negative 2 plus x is going to be 1. So that's what we wanted to happen. And so it does leave us with y. And on the right-hand side, we've got 4x plus 3 over, I'm going to write it as x minus 2. You can do negative 2 plus x, but I'm going to write it as x minus 2. And there is the inverse of that original function. Now, again, if you want to check this, you could take this inverse and put it in place of x in function f, and you should get x. And you could take this original function f of x and put it in for x in this inverse, and you should still get x. That's a really complicated thing to do. I wouldn't recommend doing that, but you could. So if you wanted to check yourself, that is a way to check. Now, if you have questions about any of this stuff with inverses, this is kind of something that is going to be somewhat new to you. It is something that we're going to kind of build on over the next week or so. And hopefully, if you have any questions, you can let me know, and we'll try to address any of those that you might have.